Hello students, this is the first video of the chapter Light, Reflection and Refraction in CBSE and Optics in Matriculation. We see a variety of objects in the world around us. However, we are unable to see anything in a dark room. On light up the room, things become visible. What makes the things visible? An object reflects light that falls on it. This reflected light, when received by our eyes, enables us to see things. Light is a form of energy which travels in a form of waves. The path of light is called ray of light, and a group of these rays are called beam of light. By observing the common optical phenomena around us, we may conclude that light seems to travel in straight line. The fact that a small source of light casts a sharp shadow of an opaque object points to the straight line path of light, usually indicated as a ray of light. Any object which gives out light are termed a source of light. Some of the sources emit their own lights and they are called as luminous objects. Properties of light. All the stars, including the sun, are examples for luminous objects. We all know that we are able to see objects with the help of our eyes. Properties of light. Light is a form of energy. Light always travels along straight line. It does not need any medium for its propagation, that means traveling. The speed of light in vacuum is 3 lakh kilometers per second. Light consists of 7 colors. Different colored light has different wavelength and frequency. Reflection of light. When light falls on a reflecting surface such as mirror, it is sent back into the same medium. This phenomenon is called reflection of light. The diagram explains the laws of reflection of light. There are two laws. One is the angle of incidence is equal to the angle of reflection. What is angle of incidence? The angle between the normal and the incident ray. And what is normal here? The perpendicular line from a plane mirror or reflecting surface is known as normal. The angle between a normal and the incident ray is known as angle of incidence. And the angle between normal and a reflected ray is known as angle of reflection. So here the law says the angle of incidence is equal to the angle of reflection. The second law, the incident ray and reflected ray and the normal to the mirror at the point of the incidence lie in the same plane. So I already told you what is normal. Here it is a perpendicular line to the reflecting surface. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. Dear students, you must know that formation of image by a plane mirror. Everyone know about the plane mirror because everyone use mirrors. There is a plane mirror. Image formed by a plane mirror is always virtual and direct. What is virtual? Virtual means that cannot obtain. Virtual image means that cannot obtained on a screen. The size of the image is equal to that of the object. The image formed is as far behind the mirror as the object is in front of it. Suppose you are standing in front of the mirror, you are moving towards the mirror, the image also it appear to move towards you. So that is the phenomenon. Further, the image is laterally inverted. What is laterally inverted here? It means the left appears right and right appears left. So in front of the mirror, you are standing in front of the mirror, you can see that if you raise your left hand, it appears to right, and if you raise your right hand, it appears to left. So that is laterally inverted. Spherical mirrors. The curved surface of a shining spoon could be considered as a curved mirror. So there is a plane mirror, now we are talking about a curved mirror. The most commonly used the types of curved mirror is the spherical mirrors. The reflecting surface of such mirrors can be considered to form a part of surface of a sphere because they prepared from the sphere only. Such mirrors whose reflecting surface are spherical are called spherical mirrors. The reflecting surface of a spherical mirror may be curved inward or outwards. A spherical mirror whose reflecting surface is curved inwards. The reflecting surface is curved inwards, that is, faces towards the center of sphere, is called a concave mirror. A spherical mirror whose reflecting surface is curved outwards is called a convex mirror. There are two types of spherical mirrors. One is concave mirror, the other one is convex mirrors. Before we move further on spherical mirrors, we need to recognize and understand the meanings of few terms. These terms are commonly used in discussion about spherical mirrors. The first one is center of curvature. The reflecting surface of a spherical mirror forms a part of a sphere. This sphere has a center. This point is called the center of curvature of a spherical mirror. The second one is radius of curvature. The radius of sphere of which the reflecting surface of a spherical mirror forms a part is called the radius of curvature of the mirror. Next one is pole. The center of the reflecting surface of a spherical mirror is a point called the pole. It lies on the surface of the mirror. The pole is usually represented by the letter P. Principal axis. Imagine a straight line passing through a pole and the center of curvature of a spherical mirror. This line is called principal axis. Principal focus. The principal focus or focal point of a spherical mirror or a lens is the point on the principal axis where parallel light rays after reflecting or refracting either converging or appear to diverge from. Focal length. The distance between the pole and the principal focus of a spherical mirror is called the focal length. It is represented by the letter F. Is there a relationship between the radius of curvature and focal length of a spherical mirror? For spherical mirrors of small aperture, the radius of curvature is found to be equal to twice the length, focal length. We put this as R equal to 2F, or you can say F equal to R by 2. So you can see these all the terms in the diagram. You can see the center of curvature, pole, principal focus, radius of curvature, principal axis and focal length. Reflection by spherical mirrors. Reflection by spherical mirrors. A ray parallel to the principal axis after reflection will pass through the spherical principal focus in case of concave mirror or appear to diverge from the principal focus in case of convex mirror. A ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a concave mirror after reflection will emerge parallel to the principal axis. This is just opposite to the previous point. The ray passing through the center of curvature of a concave mirror are directed in the direction of the center of curvature of a convex mirror after reflection is reflected back along the same path. A ray incident obliquely to the principal axis towards a point P, pole of the mirror, on the concave mirror or a convex mirror is reflected obliquely. The incident and reflected ray follows the laws of reflection at the point of incidence, making equal angles with the principal axis. So, you can see the illustration in the slide. Dear students, thank you for watching this video. Please watch my videos again and again to understand the core concept of the topics in this chapter. I will publish more videos in this chapter. You have to read your books again and again to understand more and try to answer the questions in the book. Thank you and have a nice day.